Hello, my name is John Graves. I teach science education at Montana State University. I work in a program called the Masters of Science and Science Education program. I primarily teach online. One of the things I am doing in my profession, though, is taking a look at how the K-12 science framework and the next generation science standards play into science education. The purpose of this podcast is to talk about the disciplinary core ideas as they're laid out in the next generation science standards. So as a reminder, the standards are simply that. They are standards and they are not curriculum. So as people begin to take a look at the standards, oftentimes they have this disconnect with, well, what do we teach? So keep in mind that the statements in the standards are that. They're standards, they're those broad, overarching ideas that students need to know at particular places along their learning. So the core disciplinary ideas themselves are not facts that students need to know. Instead, they comprise that core knowledge that students are expected to know, again, along that continuum from kindergarten all the way through high school. I'm going to read to you from the standards themselves the four principles that people should keep in mind as they are thinking about the disciplinary core ideas. The first one is that the core ideas have a broad importance across multiple sciences or engineering disciplines, or they need to be a key organizing principle of a single discipline. The second point is that they provide a key tool for understanding or investigating more complex ideas and for solving problems. The third thing is they need to relate to the interests and life experiences of the students, or they need to be connected to societal or personal concerns that require scientific or technological knowledge. And lastly, they need to be teachable and learnable over multiple grades at increasing levels of depth and sophistication. That is, the idea can be made accessible to younger students, but is broad enough to sustain continued investigation over years. So let's take a look at what that would mean. I'm going to take one of the disciplinary core ideas. In this case, I'm taking a look at physical science number 3, which has to do with energy. At the kindergarten level, you can read what the statement says, the standard is, and generally summarizing, it's basically we have sunlight and it warms Earth's surface. So the performance expectation at that level is described that students need to make observations to determine the effects of sunlight on the Earth's surface. Another one of those performance expectations is that students need to take tools and materials and make something that will reduce the warming effect of sunlight on a particular area. So students are introduced to energy, solar energy, at the kindergarten level. It's expected that they will continue to learn more about energy in grades 1, 2, and 3, because at grade 4, then they need to be introduced and they need to know a definition of energy, especially conservation of energy and energy transfer. And a performance expectation at that level states that students need to apply those scientific ideas, and they have to design, test, and refine a device that converts energy from one form to another. So as a teacher, imagine the lessons that will need to be taught in a sequence to get students to the point where they can actually do that performance expectation at the 4th grade level. In 5th grade, this same energy principle is now being applied in chemical processes and everyday change. Students are now asked to take this notion of energy, again, this broad conception of energy, and begin to build a model that describes the energy in animals' food and the fact that that energy once came from the sun. So you can see how this is building along the continuum from one grade to another. In middle school, the performance or the statement again is that development of energy, the definition of energy, and then the performance expectation is that the students need to plan and investigate to determine relationships now among energy transfer. So the type of matter that's involved in this energy transfer, or the energy, whatever the energy is in, the mass of that matter, the changes in average kinetic energy of the particles is measured by the temperature of the sample. So again, as teachers, think about all the things that students need to be able to know to perform this particular performance expectation at the middle school level. By the time we get to high school, there are actually numerous standards related to energy, and this is just one of them. And again, it's this definition of energy and the fact that it's a quantitative property of a system. And students have been talking about systems all the way from kindergarten through now high school. So they understand what a system is. And that system depends on the motion and interaction of matter and radiation. See, these terms are also built into those prior standards that we saw at kindergarten, fourth, fifth, and middle school levels. As I continue to read on, there's a single quantity called energy that's due to the act that a system's total energy is continually transferred from one object to another and between its various possible forms. So students have been doing a lot of these investigations and a lot of these explorations along the way, and now they are putting it all together to be able to investigate at a much higher level once they're in high school. Again, remember back to what I said earlier, that the next generation science standards are not based on facts. So we're not teaching students facts. Instead, we're teaching them these broader concepts that can be applied across lots of areas in the students' lives. So if you were to take a look at this on a continuum from kindergarten through high school, you can see where these standards fall along that continuum. If you take a look at the appendix for the next generation science standards, Appendix K maps out some possible ways that you might begin to think about organizing the standards in terms of courses at the middle school and high school level. And this is not meant to be a clear presentation of this description, but instead what I really wanted to highlight was the fact that the energy standard is found in multiple places along the way as we begin to think about what courses may look like. So in the course number 2 is basically a life science course, but you can see how the energy principles from the course number 1 will begin to apply in ecosystems, interactions, energy, and dynamics. It also plays out in waves and application for technology for information transfer. That also plays out into the 3rd course over there when we talk about life science standards of biological evolution, unity, and diversity. It plays as we begin to talk about earth science, earth systems, and also earth science and human activity. The appendix also has a fairly complicated concept map or mind map like this, showing how those principles, standards are going to apply across different courses as well. And again, this is just for diagrammatic purposes, no other reason, but to show you that this is a very complex way to think about how these concepts are going to transfer across multiple grade levels. So back to one of the things that I mentioned early on in the podcast is the ideas behind, the principles behind these core ideas are that we have this broad importance across multiple sciences or engineering practices. We are providing a key tool for understanding or investigating those more complex ideas and for solving problems. We are relating to the interests and life experiences of students. And finally, we are making sure that what we're doing is teachable and learnable across multiple grades at increasing levels of depth and sophistication. It will be a challenge for educators to begin to put the curriculum together, but I think we should always start in mind with those large concepts as laid out in the next generation science standards, taking a look at where those standards are expected to be known by the students along that continuum through the grade levels, and then build our curriculum to support having students be able to master those standards at those grade levels. Hope this has been helpful, and I hope also that it creates some further discussion. Thank you.